So as Marcia mentioned, I'm gonna briefly present the RAWMINA project. The RAWMINA project is called, RAWMINA is the short name, the long name is Integrated Innovative Pilot System for Critical Raw Materials Recovery from Mine Waste in a Circular Economy Context. This project is a European project that was funded under a program regarding the circular economy. It's an innovation action, meaning that we are targeting TRLs that go from 4 to 7, and it was funded under this specific topic. We have a total budget of around almost 11 million euros with a European contribution of around 9 million euros. And this project is working thanks to the close collaboration of 19 partners that I'm going to show you later that are coming from 10 different countries. And this project has a duration of 48 months. It started in May 2021, so meaning that today we are at month 35. So we have a bit more than a year to finish the project. And the main concept of the RAWMINA project is to develop the RAWMINA pilot system. And this pilot system is going to be an industrially scalable and flexible system for mine waste valorization. And it's going to be working in a continuous operation. We are targeting the recovery rate of specific critical raw materials that are present in this mine waste, meaning and specifically cobalt, antimonium, germanium, and tungsten. And we are targeting a recovery rate of 95%. There is also other valuable metals present in this mine waste that also we are targeting to recover them. These are gold and silver and other iron-based compounds that we can recover from this mine waste. And we are targeting an 80-90% recovery with a selectivity of 95%. And this pilot plant is going to be able to treat between 100 and 150 kilograms of mine waste per day. At the end, what we are targeting is changing this linear mining model where we have some mine waste that are not used. So we are using as an input of the project this mine waste to really recover the different critical raw materials that are present there in low concentrations, but they are present there. The consortium, as I mentioned earlier, is formed by 19 partners. Here we have different levels, no different entities. We have RTOs, we have universities, SMEs, and large enterprise. It's formed by people from the companies from 9 different European countries, the ones you can see here. So we have Spain, France, Italy, Germany, Czech Republic, Greece, Ireland, Kingdom, Finland. And we also have a South American country. So we have 2 different partners from Chile. So we have LEITAT, Chile, and we also have CRM-GRI. And with all this, we are working on the RAWMINA concept, on the RAWMINA process. This is a summary of the concept. It can be a bit overwhelming the first time you see it, but I'm going to try to explain little by little. The starting materials I mentioned earlier is mine waste. We are working with mine waste from Spain and from Portugal. The first step and the first technology development is a bioleaching process. We have 2 partners involved in the optimization of this. And from this bioleaching, what we get is a liquid, the leachate, that is formed by, is composed by different, some of the different target critical raw materials and a high concentration of iron. And this is why we had a full work package dedicated to the iron removal, with an expert partner on this to be able to recover different iron compounds. This is important to be able later to recover the other critical raw materials and also to valorize this specific fraction. Then also from the bioleaching, we also have a solid residue with the part that was not able to bioleach with this process. So here we can recover the silver and the gold, and also we get a leachate with other critical raw materials that are not in the leachate part. So with this, we get at this point with 2 different liquids. with the target critical raw materials. So then what we do is we are developing a nanofiber system with different particles that we put inside with absorption capacity to the target critical raw materials. With this, we put it in contact with the leachate solution, we absorb the critical raw materials, and then we undergo a desorption process. And with these solutions containing single critical raw materials, we undergo electrowinning to get them as a solid. From the fraction after the recovery of the critical raw materials, we still have a solution with several methods. So we undergo electrocoagulation for two main points. So one is to recover another fraction with the different metallic compounds, and also to produce water that we can reuse within the RAWMINA pilot system. In the technical discussion that we are going to have later, Diego is going to talk specifically about this point, the part of the materials for the absorption, desorption of the target critical raw materials. We have different partners, as I mentioned earlier, and regarding the value chain, we have from mine waste providers. So we have three different partners that are mining companies here. CLC is the mining company where the pilot plant is gonna be located. Here you have a photo of the facilities where the pilot plant is gonna be installed. We also have technology providers with the different universities and the different SMEs, engineering and demonstration specialist partners. We are also covering the sustainability and circularity aspects of the project. And of course, we're also working on the standardization, market uptake, business upscale. And we also have the end users of the technology of the RAWMINA process that are the same as the mine waste producers. Regarding the timeline, so it's a 48-month project, but we can divide different stages. We had the first part with optimization and the upscaling that was around 16 months. And in this first stage, what we had is the optimization of the different technologies in parallel. So we were optimizing the mine waste pretreatment, would say the beneficiation of the mine waste, the bioleaching, the iron removal, and the development of the adsorption materials. After this, we had the second stage, that is a validation and integration. So we put all the technologies together, working on a scale-up of the system. And the last stage, that is the system engineering and the demonstration, that is what we are today. So today we are kind of here. And of course, in parallel to these three main technical stages, we also had the sustainable assessment and social innovation, the exploitation, communication and dissemination, and of course the scientific coordination of management of the project. So we are here right now. We have almost completed the pilot system design. We also have almost ready all the mine waste that is going to be treated in the pilot, and the pilot is going to be commissioned next month 36 of the project, having this last year for the validation of the process. Since we are at a point quite advanced of the project, of course we have some confidential information that I cannot be sharing, but I can give a brief overview of what has been achieved so far in the project. And here I'm going to be talking mainly about the lab scale and the bench scale validation that we had in these first two stages of the technical part. So regarding the mine waste, we had different mine waste providers in the project, but we also checked mine waste from outside the consortium. So we had an initial screening to select and process and characterize, and finally getting the selection of 3 mine waste that are going to be used in the RAWMINA pilot system. We also have been working on the continuous bioleaching of these mine waste, achieving a 100% leaching efficiency for cobalt and a 70% for antimony. The alkaline leaching, if you remember, it was coming from the solid residue of the bioleaching. So here, the alkaline leaching was optimized, achieving 90% recovery of tungsten. For the iron removal, so to remove this high concentration content of iron, the process was optimized to achieve a 90% separation recovery of iron components. Regarding the absorption, we have developed 4 different nanofiber systems for the 4 target critical raw materials that we are having in the project. Regarding the desorption, also we have optimized the parameters for this. Regarding the electrowinning, the parameters are optimized for cobalt, antimonium, and germanium. Regarding the electrocoagulation of the other metals that are also present in the solutions, we are achieving a recovery of 95, 100%, depending on the metal. And we are right now working really hard on the pilot plant construction and commissioning. And here you can see some photos of the bench scale that is going to be kind of integrated now in the pilot system for the different parts of the RAWMINA process. As part of the communication in the RAWMINA project and together with Crowd Helix, we have created the RAWMINA Helix. The raw materials helix. Marco is going to talk a bit more in detail about this, but here you have the link. I can also share this link in the chat later so that you can take a look of this helix. And with this, I just want to conclude my presentation just giving you the contacts of the main people of the RAWMINA project. So in terms of coordination, LEITAT is coordinating the project, and it's Diego, Gerard, and myself. Regarding the part of communication, Crowd Helix is the communication manager, and specifically we have Marco as our communication manager. For the exploitation, we have Inlecom, and Colin is our exploitation manager. And with this, I just want to thank you